Therefore, algorithm is referred as it is a sequence of finite steps to solve a particular problem. So whatever the input I'm going to give, for that the algorithm must able to produce one output. If I execute two or more lines together, then it is parallel instruction. Hello friends, a warm welcome to my new session on design and analysis of algorithm. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, in this session, we are going to deal with definition of algorithm, use of the algorithm. Along with that, we are going to deal with the characteristics of an algorithm. Before going to start today's session, let me to discuss what is an algorithm. I hope most of the students are very familiar with the word algorithm. They studied in their C programming. So what is an algorithm? Algorithm is nothing but finite set of instruction used to solve the problem. In the sense what? Definitely I'm going to tell in this step or this many steps I require to solve the problem. For example, think that I have the problem to add two numbers. So what is my problem here? To add two numbers. Now I want to tell in definite number of steps I require to find the sum of two numbers. So here I'll start with step 1. It is nothing but the start. After that, I'm going to have the step 2, that is what I want to do. I want to read two inputs because what's my problem statement? Adding two numbers. So how many input? Two input. For example, I'll write read A and B. So these are the two input. After that, what I want to do? I want to perform summation. In my step 3, I will write sum equal to A plus B. After finding sum, what I want to do next? That is step 4, print sum. After printing, I want to stop. So step 5, stop. To solve this problem, how many steps I required? I required only 5 steps. So this is known as algorithm. So the word algorithm means a set of finite rules. So what is algorithm? It is a set of finite set. It's a finite set of instruction or rules followed in calculation or other problem solving operation. Exactly how many steps I require to solve the problem. So finite number of steps. It is a procedure for solving a mathematical problems in a finite number of steps that frequently involves recursive operation. So I can use recursive operation or non-recursive operation. Therefore, algorithm is referred as it is a sequence of finite steps to solve a particular problem. Now, dear student, if I consider this flow chart, okay, let me to define what is algorithm. So, dear student, if I consider this flow chart, I'm going to have the input. Then I'm going to have the set of rules. Along with that, I can expect the output. So here, set of rules to obtain the expected output. See here, what is my problem statement I had? That is adding two numbers. So what is my input statement here? A and B. And I want to find this sum. So what's my calculation part? That is sum equal to A plus B. And what's my outcome? That is my output. That is, I want to print sum, or I want to get the summation of two numbers. Now, dear student, if I consider the use of algorithm, in which are the fields we can able to use algorithm, that is computer science. The first field is computer science. So, dear student, algorithm forms the basic of computer program. So, we are familiar with programming language. We have C, C++, Java, Python. Okay, we have so many programming language. And whatever the problem statement we have, before going to implement that problem into program, what I want to do? I want to write the algorithm. What is my first step when I get the problem statement? I want to analyze the problem statement. For that problem statement, I want to write the algorithm. So, algorithm plays very important role in computer science. That is, if I want to sort any number, if I want to search any number, for all those things, I want to write the algorithm. Then, if I consider mathematics, in mathematical field also, we are going to use algorithm. That is, finding the optimal solution. There are certain time I want to find the exact solution. Instead of that approximate solution, in that time I'll go with an algorithm. Next, I'm going to have operation research. So this is also one field. Okay, fine. Here also we are going to use algorithm to make a optimum and to make decision. So to take any approximate or exact decision, we are going to use operation research. In that, okay, the fields are transportation problems, or we can have the resource allocation problem. We are going to use algorithm. And if I consider artificial intelligence, it's a trend, right? In artificial intelligence also, we are going to use algorithm. So, algorithms are fundamentals of artificial intelligence. So, whatever the suggestions or whatever the information we are going to get, that is based on the algorithm. So, what is artificial intelligence? It's nothing but a man-made thinking device. Okay. So, it is created by using algorithm. So, in artificial intelligence as well as machine learning, okay, we are using algorithm. So, that is, they are used to develop intelligent systems such as image recognition or natural language processing as well as decision making. We are using algorithms. Then we have data science. So what is data science? We know what is data. Data is nothing but the raw fact. And we have massive amount of data, and that cannot be processed by the traditional database management system. Now I want to extract meaningful information from that data. For that, we are going to have the data science. In data science, to process, to analyze what kind of instruction we have, all those things, we are going to use algorithm. Especially the fields like marketing, finance and healthcare sector, we use algorithm. So these are the certain fields where we can able to use an algorithm. Now, if I consider the characteristics of an algorithm, what is the first characteristics? That is well-defined instruction. What is well-defined input or instruction? So it is well-defined input. Okay, whatever the input I'm going to specify, there is no confusion, there is no ambiguity. So inputs are specified or mentioned clearly and clear and unambiguous. So whatever the instruction I'm going to write, that is clear and there is no conflict between the instruction. So that is unambiguous. Then language independent. So what is language independent? See here, if I write the algorithm, okay, that is not specific to one programming language. For example, I'll consider old example itself, that is nothing but the adding two numbers. That is nothing but the summation of two numbers. Okay, fine. In summation of two numbers, what we are doing? We are finding the sum of two numbers. So that can be implemented either using C programming, C++, Java, .NET or Python. So whatever the algorithm I'm going to write, it is not specific to the programming language. So it is language independent. If I write the algorithm to find the sum of two numbers, same algorithm can be used by C programming, C++ or Java or Python. Now, next I'm going to have feasible. See, whatever the feasible solution we are going to get, and whatever the solution we get, it is approximate or it is exact. So I want to check the feasibility of the output. So I know what is input, okay? I know what are the computation I want to perform. After performing computation, what kind of output I'm expecting. All those things are defined. Next, fitness. That is nothing but the finiteness. So exactly where I want to stop. That is in the sense from where I'm going to start. Okay, after completing how many steps I'm going to stop my process. That is also defined. At the same time, okay, well-defined output I'm expecting. See here, if I have problems like adding two numbers, exactly I know what is my output. If I have some mathematical problems like integration or differentiation, okay, or finding the roots, okay, that time I'm going to get some approximate output. So it is very important to get the well-defined output. So these are the characteristics of an algorithm. Now, dear student, I'm going to have the properties of an algorithm. So the algorithm should terminate after finite time. See here, finite step and finite sum, both are similar. That is, finite set and finite time, both are similar. So after completing this much steps, what I want to do? I want to exit. It should produce at least one output. So whatever the input I'm going to give, for that the algorithm must able to produce one output. It should take 0 or more input. There are certain time, okay, if I'm assigning the values, then I'm not going to read the input. Okay, so it is considered as 0 input. So the algorithm is designed in such a way that it's capable to take either 0 or more input. It should be deterministic, means give the same output for the input case. So whatever the input case I'm going to give or I'm going to write in my algorithm, okay, it must able to produce correct output. Each step in the algorithm must be effective. In the sense what? Whatever the steps I'm going to write in the algorithm, each step must capable to perform some task. So every step should do some work. So these are the properties of algorithm. Now, if I consider the type of algorithm, first I'm going to have brute force algorithm. So here in my brute force algorithm, what I will do? I'm trying to find the solution. Okay, so I will put all the efforts to find out the final solution. Even I can go with the trial and error method to get the solution. So in brute force algorithm, what I will do? It's a straightforward approach. At any cost, I want to get the output. So I'll try all the possibility to get the output. So see here, I have 4-digit pin. What I have 4-digit pin, okay, by using 4-digit pin, for example, say I have the numbers 1, 2, 3, 4. Okay, so the digit may be 0 to 9. So what I'll do, I'll consider 1, 2, 3, 4. Now I'll try to form the pin, that is 1, 2, 3, 4. After that, I'll try 2, 1, 3, 4. Next, 2, 3, 1, 4. So I'll try all the possibility to get my final solution. So that is my brute force technique. Okay, fine. Recursive algorithm. So what is recursive algorithm? Recursive in the sense what? Calling same function again and again. Okay, see here, I have the method or function called add. Okay, within this method, what I will do? I'll call the same method. Then it is known as recursive function. Then what about recursive algorithm? So we are going to call the algorithm within the algorithm until the given condition is true. When the condition is false, exit. So a recursive algorithm is based on recursion. The problems are broken into several subparts and call the same function again and again. So what I will do, I'm going to break the complex problem into smaller problem. That is, think that, okay, add itself the complex problem. So what I will do, I'm going to break that into smaller task, and I'm going to call the task in order to get my solution. Searching algorithm. So what is searching algorithm? We are familiar with linear search, binary search, etc. So what is searching? In a given list of element, I want to find the particular element. So the particular element is nothing but the key. So I'll consider particular element as key. So searching algorithm are the one of that you are used for searching elements or group of elements. Now I have sorting algorithm. So what is sorting algorithm? Arranging the element either in ascending order or descending order. So I'm going to have set of element. Okay. So what I want to do? I want to arrange those elements either in ascending order or descending order. Most commonly we have bubble sort, selection sort, insertion sort, quick sort, merge sort, etc. So these are the certain sorting algorithm. Now I have hashing algorithm. So what is hashing? Hashing algorithms work similar to the searching algorithm. It's similar to searching algorithm, but in hashing we are going to consider index. So they contain an index with the key. In hashing algorithm, I'm going to have the list of element. Okay, to search particular element, I'm going to consider the index as well as key ID. So in hashing, key is assigned to the specific data. And I have another type of algorithm that is divide and conquer. So what is divide and conquer? In divide and conquer technique, okay, what I'm going to have? I'm going to have some complex problems. So what I will do, think that I have large problem. Okay, what I will do, I'm going to break this problem into 4 sub-problem. Now what I will do, I'm going to find the solution for individual problem. After finding the solution, what I will do, initially I'm going to club these 2 solutions in order to check my final solution. Okay, so I'm going to club these 2 modules. Now if these modules are working properly, I'm going to club in order to get my final solution. So dividing the entire problem, find the solution, then conquer the problem is known as divide and conquer. So complex problems are broken into smaller pieces. Find the solution for that pieces. At the end, combine all the pieces in order to get the final solution. So these are the certain type of algorithm. Okay, fine. Now we have fundamentals of algorithmic problem solving. Suppose if I want to solve any problem, what are the things I want to consider? So what are the things I want to consider? If I want to write the algorithm, I can have simple problems, even I can have complex problem. But the fundamental steps are same. Okay, even the problem is simple or complex, it won't matter. But while writing algorithms, I want to follow these many steps. Okay, fine. What is my first step? Understand the problem. Okay, whatever the problem you're going to get, go through that problem properly. Okay, read that problem statement at least 2 to 3 times in order to understand the problem properly. It is better to read and go through the problem statement at least 2 to 3 times. Okay, you have to understand what kind of problem. Is it simple problem? For example, adding two numbers. It is a very easy problem. Okay, fine. If I tell you to write the algorithm to find the shortest distance, then it's a little bit complex problem. Okay, now writing algorithm to the simple problem and complex problem is different. So here I want to understand what kind of problem statement. Either it is simple or it is easy. After that, you have to decide on computational means. Okay, so what kind of computation? Here I want to decide what kind of computation. Here, if I consider computational means is nothing but computational device. Okay, if I consider computational device, I'm going to have sequential instruction and parallel instruction. So what is sequential instruction? After completing one instruction, if I complete another instruction, then it is called sequential instruction. Then what about parallel? If I execute two or more lines together, then it is parallel instruction. So I want to decide what kind of device I'm using, either sequential device or parallel device. Okay, fine. Now I want to find out exact versus approximate. If the problem statement is simple, I can expect exact result. If the problem statement is complex, then okay, I can expect only approximate result. For example, if you have the sum 4, okay, it is exact. Answer is 4. For example, if you have 6.71234, it is approximate to 7. Okay, so based on the problem statement, I can have the exact and approximate output. Next, problem solving technique. Okay, what is problem solving technique? How we are going to solve the problem. So in problem solving technique, I can able to go with divide and conquer technique or brute force technique. So exactly I want to find out which problem solving technique I'm going to use here. Next, you must have algorithm design technique. So algorithm can be designed using 3 ways. That is using natural language, using pseudocode, and another one is flowchart. So if I go with the natural language to design an algorithm, okay, it is easy. Anyone can very easily understand natural language. That is nothing but the English language. Okay, fine. Instead of that, if I use pseudocode, it's a combination of natural language as well as it's a combination of programming language. So the few members may able to understand the pseudocode. Okay, and another algorithm design technique is nothing but the flowchart. So represent the problems in terms of pictures. Okay, these are the certain algorithm design technique. Okay, after that, I'm going to have design an algorithm. Okay, so everything is finalized. Okay, what kind of system I want to use? Is it a serial system or is it parallel system? And what kind of output I'm expecting? Is it exact or is it approximate? Okay, and what kind of problem solving technique I want to use? Either brute force or recursive or non-recursive. All those things are finalized. Okay, fine. Then I want to check the correctness. Okay, I want to prove the correctness. Okay, the correctness can be proved by using mathematical induction. Okay, by providing different kinds of input, okay, we are going to check the correctness of an algorithm. Okay, after that, what I want to do? I want to analyze the algorithm properly. Okay, if I get exact Okay, if I get the proper output, okay, fine. If I didn't get any proper output, is there any mistake in the algorithm? I want to find out. For that, I'm going to have the analyze the algorithm. Whatever the algorithm we have written, it's not proper. Then what you want to do? Go back. Okay, decide on computational means, find out the exact versus approximate problem solving methods as well as algorithm design techniques. So I want to repeat the same procedure again. After analyzing algorithm, if I'm getting correct output, so what I want to do? I want to code the algorithm. So code the algorithm in the sense what? Start implementing. So whatever the problem we have, first what I want to do? I want to write the algorithm. Once the algorithm is ready, after that what I want to do? I want to convert that algorithm to program. That's nothing but the implementation part. Based on the requirement, you can able to select the programming language. Either you can able to select C program, C++, Java, Python or .NET. So these are the fundamentals of algorithmic problem solving. Anyway, dear student, in my today's session, I started with what is an algorithm. Along with that, I have discussed some of the characteristics of algorithm and properties of algorithm and types of algorithm. Along with that, I have covered fundamentals of an algorithm. Anyway, dear student, in my next session, I'm going to deal with analysis framework. Until that, keep watching and keep learning. Thank you.